Hi, I'm Steve Higdon, and I would like to present to you the technical evaluation and risk assessment for critical crane lifts. I would like you to understand the severity of critical crane lift failures and identify what a critical lift is. I would also like you to understand the process of a critical lift permit. The crane disaster that occurred in Milwaukee, Wisconsin on July 14, 1999 has came to be known as the Big Blue Crane Disaster. On this day, a critical lift rated at 97% of capacity failed. 3 iron workers were killed, and this was number 10 of the heavy lifts that have been completed on the site to date. Ironically, this crane disaster was filmed by an OSHA inspector who was on site investigating a minor infraction. The incident ended up costing 3 lives, $100 million in structural damage, $500,000 in fines, and $90 million in lawsuits. It was a totally avoidable incident. So what is a critical lift? OSHA defines a critical lift as any lift that exceeds 75% of the rated capacity of the crane. You can determine the capacity of the crane by measuring from the center pin of the turntable on a crane to the center of the load. Anything that is over 75% or uses 2 cranes is considered a critical crane lift. The first step of critical lift planning is to know the weight of the material to be lifted. Several important calculations are contingent upon determining the right weight. Some of the more critical calculations are the type of crane, capacity, rigging, and fleet angles. Structural integrity basically means, will the material hold its own weight? It is common to build as much as you can on the ground. This minimizes fall injury, but it may increase the chance of the lift failing. The structural integrity must be determined in the critical lift planning. The critical lift process is a team effort. Safety professionals work with engineers, craft, and the crane companies themselves to ensure that these calculations are correct. 3D modeling is a very useful tool to determine these variables. Now we have to consider rigging. In this picture, the angle of the rigging is arranged in such a way that one choker holds almost the whole 50-ton load. You have to understand the angle of your rigging and the added pressure that it puts on the rigging. In this case, one choker had to be good for holding the whole load. The only way to ensure that everything is done correctly after you've planned it correctly is to put it on paper and have people sign it. That's the purpose of a critical lift plan, and it should be correctly written and stored. The proper critical lift plan will tell you what rigging should be used. As a safety inspector, you should be able to ensure that the rigging that is on the crane permit has been used. You need to check the tags and know what you're looking at in order to ensure the proper rigging has been used. Multi-crane picks are some of the most complex of all lifts. The capacity of each crane and each component of the lift must be calculated. There are also inherent dangers in signaling a 2-crane lift. You will then need to choose a crane for the specific type of application that you're going to be using. You have to know a little bit about load charts to understand what the crane is capable of. This is called the capacity of the crane, and it's very important in planning a critical lift. Now that you have developed a lift plan and chosen a crane, it's very important that you ensure the stability of where you're going to be setting up the crane. This can be accomplished through grading or mats. It can also be accomplished using steel plate. A crane will fail if it is not set up properly on a firm, level surface. After the crane has been set up properly, it is very important that you know the surroundings of the crane. One of the most important things you should look for is to make sure the crane will not come into contact with any electrical power lines. This is an extremely dangerous part of any critical lift. Also very important is to determine what is known as the swing radius. This means the area in which the load and each component of the crane will be swinging. Cranes have gantries and masts that may hit something if you don't make sure the swing radius is clear. Loads must be controlled with tag lines to keep them from swinging into other objects or other pieces of equipment. It is very important that you control the load and make sure that no one is walking under the load or around the load. Before beginning your pick, and it will be noted on the critical lift permit, the crane should be thoroughly inspected by competent people. This includes miking the cable of the crane to make sure it's not worn, checking the tires and outriggers, checking what's called the sheaves on the crane in the top section, checking the hooks on the crane, and the turntable of the crane. Earlier we spoke about checking the rigging. In that regard, it was to check the rigging to ensure that the rigging is the proper rigging for this lift. In other words, it's what the engineered drawing calls for. Now you should check the rigging itself for wears, tears, cracks, or other things that could cause failure. This is equally important as having the right type of rigging to make sure that the rigging that you're using isn't damaged in any way. In closing, the three most important questions in critical lifts that you should remember is: what is the weight of the load? What is the capacity of both the crane and the rigging? And is the ground stable for the weight that you intend to pick? These are questions that you and your team must answer for a safe lift. And it's not a one-person operation. Any critical lift is a team effort and will take the expertise of many people. I thank you for your time to listen to this presentation. I hope you learned something. Attached are the sources that we used for this presentation, and there are a lot of really good information. Hope you learned something. I hope you can use it in your work. Thank you.